you guys ready? Because it's recording right now. Say hi, class. We tried this before, but it wasn't working. It actually almost finished, and then it stopped recording on me, so I have to do it all over again.
You already told us that.
But they don't know this.
Wow.
All right. So yesterday we learned how to take a quadratic formula, or take a quadratic equation and complete the square. What we did yesterday was put things in vertex form so we could find the vertex. But there are other ways of doing this, and actually you guys have actually probably learned most of these ways. So let's kind of go over the basics. A standard form for a quadratic equation is y equals ax squared plus bx plus c. Did we go over this yesterday? Okay. What you guys don't know is, like, you guys have heard of the quadratic formula before, correct? The quadratic formula is right here. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, what you don't know is how they actually got that equation was they started with a standard form, they completed the square, and they got this. This is an extra credit assignment that I'm going to tell you guys about tomorrow. Okay? But that's how the professionals started with a standard form of quadratic equation, completed the square, and solved it to get the quadratic formula. So the quadratic formula actually tells you what the x-intercepts are. Now there are so many different names for the x-intercepts. What does your calculator call x-intercepts? The calculator calls them zeros. You had to find these before, correct? So the calculator calls them zeros. The old people like myself, my calculator, because it's such an old calculator, actually calls them roots. And then most of the time, anytime they ask you to solve or find a solution of a quadratic, they're actually telling you to find those x-intercepts. So they can use any one of these words that all mean the same thing. Use the quadratic formula. Okay? So let's actually go through number 2. If I'm looking at f of x equals 3x squared minus 6x plus 1, what's your a value here? A is 3, b is negative 6, and c is 1. So all you have to do is take these numbers and substitute them into the formula. Okay? So I get x equals the opposite of b. Well, b is negative 6, so the opposite of b is 6. Plus or minus the square root of b squared. What's negative 6 squared? 36. Minus 4 times your a value, 3, times your c value, 1, all over 2 times your a value, which is 3. Okay, so there's the setup. We are going to start with the square roots. So x equals 6 plus or minus. This becomes 36. What's 4 times 3 times 1? Minus 12. All over, and then 2 times 3 is just 6. Alright, so x equals 6 plus or minus 36 minus 12 is 24, all divided by 6. Now, is 24 a perfect square? No. So there's 2 options that we have to have. I might ask you guys to give me an exact answer. Okay, so exact answer means you are not allowed to use decimals, you are not allowed to round. So what do you do with this case? Square root of 24, you cannot take the square root of this number. However, you can reduce it. What's a perfect square that goes into 24? 4. So you break this up into 4 times 6. Square root of 4 is 2. So that becomes 2 root 6, correct? So this becomes x equals 6 plus or minus 2 root 6 all over 6. Now when you look at this, you cannot leave this answer the way it is. It can be reduced. So if you notice, the 6 is being divided by 6, and the 2 is being divided by 6. So what's 6 over 6? 1. Plus or minus? 2 over 6 reduces to what? 1/3. but you still have the square root up there. So it's going to be root 6 over 3. That is an exact answer. The problem with this exact answer is you don't know where on the graph it fits. You don't know what number this is. So instead of an exact answer, I'm going to erase this, I could have you guys give me a decimal answer. Square root of 6 over 3. Now, if I tell you to give me a decimal answer, all you have to do is type this into your calculator. So, you see how you have let's write it out again. You have 6 plus or minus the square root of 24 over 6. This plus or minus means you actually have two separate answers. So we're going to break it up. 6 plus the square root of 24 over 6, and 6 minus the square root of 24 over 6. The only thing I need you to do is type this into your calculator and give me a decimal answer. Now, you see how you have two terms in the numerator? That means when you put it in your calculator, make sure you use parentheses. Okay? Go do that now to make sure you can. Alright, so 6 plus the square root of 24 divided by 6 should come out to be about what? About 1.82. And the other one comes out to be about 0.18. Now remember, what are you actually finding? You are finding x-intercepts. These are points on the graph, so how should you write them? As ordered pairs. This is the point 1.82, comma 0, and this is the ordered pair 0.18, comma 0. So these are the answers that I'm actually looking for, as written as ordered pairs. So let's scroll down to where the graph is and put those on the graph. So we got to make our axes. And I got two x-intercepts. One is at 1.82. So 1.82 is about here. And then 0.18 is about here. Okay. So I've got my first 2 points. Does anybody have any questions right now? Alright, step 2. What's the next part? Find the vertex. Okay, now, yesterday we learned that if you complete the square, you put it in vertex form, you can get the vertex, correct? Today, I'm going to show you another way of getting the vertex. It's up to you which way you want to use, but this is another way of getting the vertex. And you're actually going to use part of the quadratic formula. You're going to use the part that is not in the square root. So x equals opposite of b over 2a. This right here, this part, actually tells you how to find the vertex. So that formula, and we're going to keep with number 2 here, x equals the opposite of b over 2a, that will actually give you the vertex. So again, what was the opposite of b? It was 6 over 2 times your a value, which is 3. So I get 6 over 6, which is 1. A vertex is a point. Again, these are all ordered pairs. It's a point. I only found the x part. So I found that x is 1. Well, anytime they tell you x, how can you find y? You plug it back in. So you're going to plug in 1 into that original equation up here. Okay, so 3 times 1 squared minus 6 times 1 plus 1. Make some more space. Yep. Alright, I'll address that in a second. Okay? Actually, so this whole term just becomes 3. 1 squared is 1 times 3 is 3. This becomes minus 6 plus 1. Now what's 3 minus 6 plus 1? Negative 2. Okay, that's your y value. So this vertex is an ordered pair. What's the ordered pair here? 1, negative 2. Okay, so let's put that on the graph as well. 1, negative 2, right here. So you're starting to see the symmetry here, yes? No? Okay, I'm going to put a little V for vertex. Yes? That's right, it will be open. So you can see right now the vertex is down here and it opens up, which is right. And it's going to be a narrow parabola, right? Good. Alright, next part. Find the y-intercept. Well, how do you find the y-intercept? 0 for what variable? For x. So to find the y-intercept, you plug in 0 for x. Now this is actually the easiest part here. If you plug in 0 for x, what happens to this thing? 0, this one? 0. And what are you left with? 1. So your y-intercept is actually always the c term, no matter what. But again, it's a point on the graph. So what is this point for number 2? 0, 1. So 0, 1, put that dot there. We're going to call that the y-intercept. So we're having all these points labeled. And on this graph, they also ask you to use a symmetrical point down here. So it says use a symmetrical point to the y-intercept. So a parabola is symmetrical. If you split it right down the middle, it's the same on both sides. So I'm going to show you guys. I'm going to split this thing right down the middle. Here's the vertex. I'm going to split it right through the vertex. Now from this line of the vertex, how far am I to get to that y-intercept? 1. So that means if I go 1 to the other side, I'm going to have its symmetrical point, correct? So this right here, that's called the symmetrical point. Question?
Like those decimals in the part 1, do you just estimate where they are?
Yes. So yeah, for the x-intercept, you are just estimating those. Okay, so now that we have all these points, now we have 5 points. Let's graph a parabola, making sure it looks like a U shape. Okay, and now we can answer these questions down here. The axis of symmetry, which means what's the line that cut this parabola in half? That vertical line that we drew in here? This right here is the axis of symmetry. Okay? It's a vertical line. How do you write an equation of a vertical line? X equals, and then in this case it crossed the x-axis at 1, so the axis of symmetry is x equals 1. And then this next part says, find the max or minimum of f of x. Well, f of x is a fancy way of writing y. So you ask yourself, do you actually have a max? No, these arrows point out this graph and go up forever. Do you actually have a minimum? Yes, the minimum is actually at the vertex, correct? It's always going to be at the vertex. Is this it's the minimum? What's the lowest value? -2. The lowest y value on this graph is -2. Alright, turn your papers over. And at the top, it's got a very important statement that we are going to hear. All quadratic functions have 2 solutions. And here's why. What's your biggest exponent in a quadratic? Squared. Because it is squared, I guarantee you that you will have 2 solutions. Okay? The biggest exponent tells you how many solutions you will have. So just so I can show you guys. If I gave you this function right here, 3x to the 4th plus 3x squared plus 1, how many solutions are you going to have? According to this equation, in this situation, I would have 4 solutions. Okay? So that biggest exponent always tells you how many solutions you are going to have. Guaranteed. but they try to trick you. So let me show you a basic quadratic function. If you have axes right here, and I draw just a normal parabola, this has two solutions. Now again, what's another name for a solution? A zero, keep going. A root, one more. An x-intercept. Does this have two x-intercepts? Yes, one right here and one right here. So this has two solutions. Let me draw another parabola for you. So here's my axis. What happens if I draw this parabola up here? How many solutions does this one have? You're wrong. How many does it have? It has two. All of these will always have two solutions. What's the problem here? It's not hitting the x-axis. I promise you those two solutions do exist. But since you cannot see them, they are imaginary. So in this situation, you have two imaginary solutions. Okay. Now, in the first graph over here, since we actually saw them, those are two real solutions, because you can actually see them. I've got one more type of situation here. Okay? It happens at this case right here. So I'm going to draw this. So this is the unique case where your vertex is on the actual x-axis. So how many solutions do you see? You actually only see one. We are going to call this a double root. And even though you only see one solution, guess how many are there? There's two. And I'm going to show you like an example of a double root so you guys can understand it better. If I gave you the equation x squared minus 4x plus 4 equals 0. Okay? And you can factor this. What are the factors of 4 that add up to a negative 4? Negative 2 and negative 2. So that would be like x minus 2 and x minus 2 equals 0. So if you actually solve these, like set it x minus 2 equal to 0, what would you get for an answer here? X equals 2 and x equals 2. So how many answers do you actually see here? You see two answers, but they both occur in the same spot at 2. So that's why it's called a double root. There's actually two answers there, but they're both hitting the x-axis at the exact same spot. So that's the double root part. Okay. We will show you how the imaginary solutions work in a little bit. But as of right now, it's just go along with it for right now. Okay? Alright. So, it says the discriminant helps us determine the nature of the solutions and where the vertex is located. So, let's actually rewrite the quadratic formula here. X equals the opposite of b plus or minus the square root, b squared minus 4ac, all over 2a. Do you guys have this memorized? You need to. Okay. What we said earlier was this part right here, this x equals the opposite of b over 2a. This tells you the vertex. Now what I want to see, the discriminant is actually going to be the part that's underneath the square root. This b squared minus 4ac. Okay? So, the discriminant is b squared minus 4ac. That's the important part. Now, this will tell you how many solutions that you have. It won't tell you where the solutions are. It only tells you the nature of your solutions. Like, are they imaginary? Are they real? Is it a double root? And I need you guys to pay real close attention during this part because I need this to make sense for you. When you plug in b squared minus 4ac, you type these numbers in, you could get a negative under the square root, correct? So what happens if you got a negative under the square root? That means they're some imaginary answers, right? So if you type in b squared minus 4ac, that means that you have two imaginary. Now the second part, you could type in b squared minus 4ac and get a positive number. Let me erase some of these colors so I can go through this. If you get a positive number under the square root, do you see how you have plus a number and minus a number? How many answers is this going to create if there's plus and minus? You're going to create 2. So if you get a positive number under the square root, you are going to have 2 real solutions. And I've got one more case. I've got negatives, I've got positives. What have I ignored? 0. Now the square root of 0, what happens if I get the square root of 0 though? What's 0? It's 0. Now if you come back up to this formula, if I add 0 or I subtract 0, does it make a difference? No. So how many answers am I going to have here? 1. Or what do we call it when there's only one answer? It's called a double root. So literally, all you have to do is type in these numbers and figure out, is it positive, is it negative, or is it 0? So, at random, let's go ahead and pick one of these numbers. Which one do you want to do? 4? So we're going to do 4. Okay? So let me just write it out. My A is negative 2, my B is 1, my C is negative 5. I'm going to plug these into b squared minus 4ac. Okay, well, what's my b value squared? 1 minus 4 times my a value, which is negative 2, times my c value, which is negative 5. How many negatives do you see there? 3. I've got 3 up there. So that means this is going to stay minus. And 4 times 2 times 5? It's 40. So when you subtract them, you get negative 39. This number is the discriminant. And because it's negative, what does that mean? Two imaginary. Alright. I got one more quick thing, because I also said this discriminant also tells you about where your vertex is located. Correct? Okay. When you look at this number 4, you can tell me right away by looking at this negative 2 that the parabola opens which direction? Opens down. So you know this thing is going to open down. If I draw a parabola that opens down like this, how many solutions do I have? 2 real. Is that the case that I have here? No. So what does that mean about the vertex or the location of the vertex? That vertex has to be below the x-axis. It's got to be below because when it opens down, it's not allowed to touch the x-axis. You guys understand that? So it'll actually tell you where the vertex is located. Is it above the x-axis or is it below the x-axis? Anybody have any questions? Jay? No. The only thing that the discriminant will tell you is, do you have 2 positives or 2 real solutions? Do you have 2 imaginary solutions, or do you have a double root? It doesn't tell you anything about location. It could be used to sketch the graph. It really just tells you it's a shortcut. So if they want to know, do you have 2 real? Do you have 2 imaginary? That's the only thing it really tells you. Okay? And it tells you like where the vertex is. It really doesn't give you any placement of anything. It just kind of tells you what you should expect when you graph this. Any other questions? These are great questions. Okay.